Have you ever wondered how massive ships can travel across the vast oceans? The answer lies in the heart of the vessel, the ship engine. These engines, often overlooked, are marvels of mechanical engineering. They are complex machines that power these colossal structures across thousands of miles of open sea. Understanding this machinery is not just intriguing but also pivotal to maritime travel. So let's embark on this journey of discovery together. In today's video, we will delve into the intricate details of how ship engines function. To understand how a ship engine operates, we first need to familiarize ourselves with its basic components. So let's dive in. At the heart of a ship engine is the engine block, a hefty piece of machinery made from cast iron or aluminum. This is the foundation of the engine, housing several key components that are integral to the engine's operation. Inside the engine block, we find a series of cylinders. Inside each cylinder is a piston, which moves up and down, converting the energy produced by the engine into motion. Next, we have the propeller, a crucial component that transforms the energy produced by the engine into propulsion. The propeller's blades are angled and shaped in a specific way to maximize thrust and efficiency. When the engine is running, the propeller spins, creating a pressure difference in the water that propels the ship forward. Then we have the fuel system, an intricate network that feeds the engine with the fuel it needs to run. This system includes the fuel tank, fuel pump, and fuel injectors. The fuel tank stores the fuel while the pump moves it to the engine. The fuel injectors then spray a fine mist of fuel into the engine cylinders where it is ignited to produce power. Lastly, we have the exhaust system, which is responsible for removing the waste gases produced during the combustion process. This system includes the exhaust manifold, which collects the exhaust gases, and the exhaust pipe, which releases them safely into the atmosphere. Each of these components plays a crucial role in the overall functioning of a ship's engine. The engine block and pistons work together to produce power. The propeller converts this power into propulsion. The fuel system supplies the engine with the fuel it needs to run, and the exhaust system removes waste gases. Now that we know the parts, let's see how they work together to move a ship. The heart of a ship engine's operation lies in the combustion process. This is where the magic happens, folks. It's a fiery dance of air, fuel, and heat working together to generate the power that propels the ship through the water. Let's dive a little deeper. The combustion process begins with the intake of air. As the piston moves down in the cylinder, it creates a vacuum. This vacuum sucks in a mixture of air and fuel into the combustion chamber. This is the first act of our combustion dance, providing the ingredients necessary for the next stage. Now the stage is set for ignition. The piston moves back up, compressing the air-fuel mixture. This compression heats the mixture to a high temperature, making it highly volatile. At just the right moment, the spark plug fires, igniting the compressed mixture. This ignition causes a small explosion, generating high pressure and temperature within the combustion chamber. The energy from this explosion is what powers the piston down, turning the crankshaft and ultimately the propeller of the ship. But the dance isn't over yet. The final act is the expulsion of exhaust gases. After the explosion, the piston moves back up, pushing the exhaust gases out of the cylinder through the exhaust valve. This expulsion makes room for a fresh intake of air and fuel, readying the stage for the next round of the combustion dance. This process repeats over and over, hundreds of times per minute. Each cycle is a symphony of precision and timing, with each component playing its part in perfect harmony. It's a continual cycle of intake, compression, ignition, and exhaust, creating the energy necessary to move the ship. So the combustion process is the powerhouse of the ship. But what about the control systems? A ship engine is not just about power, it's also about control. To master the seas, one must master the engine and its control systems. Let's take a closer look at these, shall we? The throttle, for instance, is a critical control system. Acting as the accelerator for the ship, it controls the amount of fuel entering the engine. By adjusting the throttle, we can control the ship's speed, a delicate balance between fuel efficiency and power. The steering mechanism, on the other hand, directly influences the direction of the ship. This is often linked to a rudder which swivels to guide the ship. It's like the steering wheel of your car, just on a much grander scale. Now, let's not forget about the engine's control panel. This is where all the magic happens. It houses various indicators and controls like temperature gauges, pressure indicators, and warning systems. It's the hub that lets you understand what's happening inside that colossal engine at any given moment. But remember, control systems are not just about maneuvering the ship, they also play a significant role in maintaining the engine's health. Regular maintenance of these control systems is crucial. Just like your car needs an oil change, your ship engine needs regular checkups too. Routine inspections can help identify any potential issues before they escalate into major problems. Are the gauges reading correctly? Is the throttle responding as it should? These are the kind of questions that regular maintenance can answer. Moreover, timely maintenance can enhance the lifespan of the engine. It ensures that all parts are functioning optimally, reducing wear and tear. It's like giving your engine a new lease on life every single time. So control systems and maintenance go hand in hand. One cannot function without the other. By understanding and maintaining these systems, we can ensure the engine's longevity and optimal performance. It's a continuous cycle of control, check, correct, and carry on. With a good understanding of control systems and maintenance, we can ensure the engine's longevity and optimal performance. Now, isn't that a voyage worth undertaking? Understanding the workings of a ship engine may seem daunting, but it's fascinating once you break it down. We've journeyed through the intricate world of ship engines today, diving into the heart of these mechanical beasts. We started our voyage with the basic components of a ship engine, from the pistons to the crankshaft. Each part plays a pivotal role in propelling these giants across the seas. We then ignited our understanding of the combustion process, the fiery heart of the engine. Fuel and air mix, combust, and the resulting energy is transformed into mechanical power, driving the ship forward. It's a process of fire and force, a dance of elements that powers these vessels on their oceanic journeys. Our exploration then led us to the control systems and maintenance of ship engines. These are the unsung heroes that keep the engine running smoothly, controlling its operation and ensuring it remains in top shape. Regular maintenance is crucial, as it prevents breakdowns and ensures the longevity of the engine. In essence, a ship engine is a symphony of parts working together, a marvel of engineering that harnesses the power of combustion to move ships across vast oceans. Each component, each process, plays a crucial part in this mechanized orchestra. And there you have it, the mechanism of a ship engine, a marvel of engineering that allows us to explore the vastness of the oceans.